Okay, so lesson 4.3, and this is part 1. This is part of our introduction to the unit circle. The unit circle being the circle over there on the sideboard, right, that I keep referring to. You have a paper copy to refer to as well. A little bit of vocabulary. And I know some of this vocabulary you saw in your video that you hopefully watched. As we look at these unit circles, first of all, one thing to notice, I've mentioned a little bit, but we're 0 degrees on the unit circle. And 0 degrees is it safe if I say 3 o'clock? Is that a good way to put it? Or 0 degrees is east? I don't know how you want it, But 0 degrees is over there at 3 o'clock is the easiest way for me to put it. When we look at all these angles, we will always refer to right here, this 0 degree side, as our initial side. So this is where your angle begins. Now, a typical angle is going to go counterclockwise. So as you see right here, a typical angle starts at the initial side and goes clockwise, so backwards around the clock. And where you end is called the terminal side. So we've got an initial side and a terminal side. Assuming you are going counterclockwise, that's a positive angle. And I think that was mentioned a little bit in your video. I watched a couple different videos, so I'm trying to remember what exactly was in yours. But as we go around counterclockwise, that's a positive angle. And so that's a positive amount it ends on. A negative angle would still start here at the initial side. It would still start at 0. But the negative angle is going to go clockwise. And so what that leads us to is every angle on the unit circle has multiple different names associated with it. When we look at, say, if I go back here and I think of this as, say, 45 degrees, just guesstimating, that has a lot of other names besides 45 degrees. And that's one of the things we're going to work with today is kind of, expressing some of that. So we're going to talk about coterminal angles. So that's a good vocabulary word there. Coterminal angles are those angles that start at the same initial side and they end on the same terminal side, but they simply swing around the center more than once. Or maybe they go around the center the opposite direction. So leading the idea of coterminal angles, multiple different names for one angle. Okay? For example, 90 degrees. Do you have a visual if I say 90 degrees? Based on the fact, I feel like I'm going to put it over here. Based off the fact that 0 degrees is at 3 p.m., right? Or at 3 o'clock. And then when we talk 90 degrees is simply starting here at 0 and going counterclockwise. There's your 90 degrees, yes? Okay, that's one name for that angle. Now, according to this, 450 is a name for that angle. Think about this with me. If we start here at 0, let me pick a different color here. If I start here at 0, what do you know about once around a circle? 360, yes? So if I start right here and I go around the circle once, that's 360, yes? How much more till I get up to this terminal side here? That's another 90 there, isn't it? And what's 360 plus 90? There's your 450. So right there, my dotted purple line, my solid orange line, those are the same angle, just different names for it. Okay, so 90 degrees, you just start at 0 and go straight to 90. Just do that quarter turn. 450, you go all the way around once, and then when you continue another 90, you're at 450. Could we keep going another 360? I mean, think about it. 90 plus 360 right here is 450. Could we go another 360? Whatever 450 plus 360 is. In other words, there are unlimited names for this circle. Now, we also have negative 270. Pick a different color here. If you recall from up above, negative says we still start at 0, but instead of going counterclockwise, we go clockwise. So if you follow here, right there would be negative 90. If I get over here at the halfway point, we're at negative 180. And then guess what we're at right up here? That's negative 270. Okay, so you have to become comfortable with the idea of which way we swing and how many times we're going around. In degrees, the key is to remember there are 360 degrees in the circle, right? Questions on those? Okay, now let's get fancier. Let's talk radians. Okay, and I'm going to tell you guys, the gut instinct at the beginning is, oh, I'm just going to make everything degrees. You need to learn to work with the radians. It's not that we can't equivalate them in degrees, but you need to learn to work with the radians. So, on this second example, the claim is that pi, 3 pi, and negative 99 pi are all the same angle. That they are coterminal angles. Okay, we've talked about pi. What's pi look like? There's my initial side. There's my 0 degrees off at 3 o'clock, right? If you recall, 2 pi is all the way around the circle, right? So what's pi? Halfway around the circle. So right here, that is pi. Okay, so over here starting at 0, that's pi. Also 180 degrees if you need that equivalence, but it's pi. Now, the claim is that 3 pi is the same. Can you process what 3 pi is doing? It's positive, so we're still going to go the same way, right? As I start here, and I go up and around, here I'm at pi. When I go once around, what am I at? I'm at 2 pi. And so then what happens when I go halfway around again? You're at 3 pi. What if we went around again? What would be the next name for this? 5 pi, right? Because you'd add another 2 pi, yes? Okay. What about this negative 99 pi? Are we really going to go around that many times? I mean, we could, but here's what you've got to think, okay? First of all, negative takes me which way? Takes me clockwise, takes me down instead. So if I start here, where am I at right there? I went negative, so I went halfway around, so right there is negative 1 pi, yes? Well, what if you keep going? If we keep going here, all the way around again, now we're at negative 3 pi. Then after negative 3 pi, add another 2 pi, and we'd be at negative 5 pi. Or I should say subtract another 2 pi. Would we eventually get to negative 99 pi? Do you feel confident in saying that is the same as 1 pi and 3 pi? Again, anything that ends right here on pi is a coterminal angle. Okay? So those are the things we're talking about, okay, when we talk coterminal angles. Yeah?
How many times around would that be? Would it be like half of 99?
Pretty much.
Half of 99 plus 1.
I'd say it'd be right around half of 99. So right around 50 times. I mean, the first time would be at 1. So yeah, I think it would be around 50 times probably. I always have to stop and think, but right around there, you get the idea that you'd be going around, circling around. Needless to say, I'm not going to try and draw it because it would turn into illegible disaster here, right? Okay, so notice all these angles we talked about, they simply differ by an integer multiple of either 360 degrees or 2 pi radians. Those ones, 90, 450, and negative 270, that was either adding or subtracting 360 every time. These radians, pi, 3 pi, and negative 99 pi, that was either adding or subtracting 2 pi every time. Okay, and of course that is because the circle measures 360 degrees, 2 pi radians. Okay, move along here. This is just without the unit circle. This is just kind of understanding what we're talking about here. Find a positive and a negative angle that are coterminal with the given angle. So we're not going to draw a picture, not that we couldn't, but we're not going to draw a picture. But I want one positive and one negative coterminal angle with 30 degrees. So what would be another name, staying in degrees, for 30 degrees?
390.
Jacob says 390. Do you like it? How would he get 390? You would take 30 degrees and you would add 360, yes? So 390 degrees would be a positive answer there. Because if you start at 30, or if you go to 30, you've got to go one whole turn around, so add 360. What's a negative angle that would be coterminal with 30 degrees?
Negative 330.
Negative 330? What's Miles doing here? He's taking 30 degrees. Instead of adding 360, he is subtracting 360. I almost forgot my negative sign. So negative 330 degrees. Are those the only two right answers for this problem? No. They're the obvious right answers, yes. They're the easiest go-to answers. But if you want to get fancy, could you give bigger answers? Yeah. Add 360 again to 390. Add 360 a couple more times. Those are equivalent answers. Okay. What about B? The difference is this time my original angle is negative 150, which is fine. It can be a negative. What would be a positive coterminal? We don't even have to go positive first, but what would be a coterminal angle with negative 150?
210.
210. Is that logical to everybody? Because what did he do? He took negative 150 degrees and added 360 degrees and got 210 degrees. Okay. What about negative coterminal angle with negative 150 degrees? What do we want to do this time? Take negative 150 degrees and subtract 360. So negative 150 minus 360. Negative 510 degrees. All names for the same angle. Okay, C. You know it had to happen. We have to talk radians here. Now, I want our answers in radians. I want to work with radians here. As tempting as it is to say, oh, okay, 2 pi over 3. Oh, okay, that's 120 degrees. I'm going to do it in degrees now. That's not what I want you doing. Okay, and by the way, where did I get that number? I was just looking at the unit circle I provided you, right? Okay. What's the equivalence? What are we going to do here? Ethan?
Are we going to add in the 2 pi radians?
Yeah. This time, if we're starting with 2 pi over 3, we're going to add 2 pi radians. Now, how do we add 2 pi to 2 pi over 3? What do we need to think about 2 pi as?
2 pi over 1.
2 pi over 1. And if we go get a common denominator, 2 pi over 1 with a denominator of 3 becomes, I heard it, 6 pi over 3. Can you agree there? Right? 2 pi over 1 is what you're going to think of here. And 2 over 1 becomes 6 over 3. So what's 2 pi over 3 plus 6 pi over 3? That's going to be 8 pi over 3. Elementary fractions, right? Middle school fractions, our favorite. Bad news about radians. Yes, you have to do a lot with fractions. So 8 pi over 3 would be equivalent to 2 pi over 3. That would be a positive coterminal angle. How do you think we're going to find a negative coterminal angle? Go back to that 2 pi over 3, and this time we're going to subtract 2 pi. And obviously, if we're subtracting 2 pi, think of it as 2 pi over 1. What's 2 pi over 3 minus 2 pi over 1? Or in other words, 2 pi over 3 minus 6 pi over 3? Negative 4 pi over 3. Okay. One of your sections in homework is going to be find coterminal angles. These are not the only answers, but these are the more obvious answers you give. Question?
Would you like us to put radians on there? Or is it...
You do not have to label radians, okay? If there's degrees, if it's a degrees, I expect to see a degree bubble. If there's no label after it, it is assumed it's radians. You can label radians, but you're not going to want to label everything we do radians. So, good question. Okay, the other thing we need to talk about today is a reference angle. And as we talk about reference angles are very key in what we do in pre-calc and with this trig, okay? You know that reference chart we set up that has the 30, 45, and 60 degree angles and all those sine, cosine, tangent? Those are reference angles. And so everything, you know, all of your basic trig functions relate to those reference angles. So notice what it says here. A reference angle is the angle that a given angle makes with the x-axis. So x-axis, right? Basically how far an angle is off of the x-axis. It is always positive, and it's always based off of subtracting to or from 360 degrees or 180 degrees. Which, think about it, 360 degrees and 180 degrees, those are your two numbers on the x-axis, right? So, always positive, and because we're always subtracting to and from that x-axis, it's always going to be a number less than 90. So, a reference angle in terms of degrees is somewhere between 0 degrees and 90 degrees. Now, what is that in radians? A reference angle in radians is somewhere between 0 radians and, what is 90 degrees in radians? Pi over 2, right? 180 is pi. Whoops, 180 is pi. So half of 180 is 90. Half of pi is what we say, pi over 2. So right there, your answer, if it's degrees, it's going to be somewhere between 0 and 90 degrees. If it's radians, it's going to be somewhere between 0 and pi over 2 radians. It's a positive number in that range. So let's look at example 1, or example A, I guess it is. Find the reference angle for each of the following. Well, first of all, 256 degrees. There's my x-axis, right? Where's 256 degrees? Can you figure it out? And not just by looking at the unit circle, but how do we figure out 256 degrees? We're going to start at 0 here, yes? Where do I go from 0? We're going to go counterclockwise. Where am I at when I've gone a quarter of the way around the circle? That is what? 90 degrees. Where am I at now that I've gone halfway around the circle? 180 degrees. Where am I going to be at if I continue all the way around to 3/4 of the way around the circle? 270. What do you know about 270? It's too far, yes? So we're looking for, what was it, 256 degrees? So 256 degrees is going to be somewhere past 180, but before 270. Agree? I just realized I don't like how I drew that. I really shouldn't have that 180 in there yet, but that's all right. We'll make it work. Now, so this right here, all the way around here, or down in here, is 256 degrees. The reference angle is how far is that angle from the x-axis. So here's my x-axis, yes? Is 256 degrees, is it closer to the 0, 360 side or the 180 side? Yeah, because it's down here in what I would say quadrant 3, yes? This is closer to the 180 side. So the question becomes, how far is that from the 180? How far is 256 from 180? So use some logical math there. 256 degrees minus 180 degrees is going to be 76 degrees, if I did that math right. So that right there has a reference angle of 76 degrees. It's 76 degrees below the x-axis. Got it? Okay. Ready to try B? B is radians. That's what makes this one a tougher one. Now, I'm going to start over here at 0, yes? Now, you can look all you want, but you're not going to find 8 pi over 7 on the typical unit circle, because sevenths is not something we work with on the unit circle. Doesn't mean it doesn't exist. So, here's what I always want you to think. Is kind of, and I'm just going to kind of dot these in. But, okay, this is 0, right? It is also 2 pi. What is this over here? Over here at 180 degrees, this is called pi. This is what I start filling in. What is 1 pi in terms of sevenths? 1 pi is how many sevenths? One pi is, what is 1? 7 sevenths, correct? 1 is 7 sevenths. So right here, here's 0. Here's 7 pi over 7. What are we trying to figure out where it is? 8 pi over 7. So what do you know about 8 pi over 7? It's going to be where? If we're starting here, and I'm tracing around, Here's 7 pi over 7. 8 pi over 7 is going to be a little bit past it. So 8 pi over 7 as well is also going to be down in the quadrant 3. Okay. It's also helpful to know up here, remember this is pi over 2, and down here is 3 pi over 2. Oh my goodness. It won't let me draw there. There we go. That's 3 pi over 2 down there. It will not let me draw in that spot. Okay, so those are good reference angles to know. What do I need to know? What's my reference angle? How far is this from the x-axis? In terms of going from the x-axis, again, it is closer to 180. But we're not going to call this 180. We're going to call this pi. Also 7 pi over 7. So what am I going to have to do here? We're going to have to take 8 pi over 7, and we're going to have to subtract off pi, which would be the same as saying 8 pi over 7 minus 7 pi over 7. And what is 8 pi over 7 minus 7 pi over 7? 1 pi over 7, or in other words, pi over 7. Okay. I'd hoped to get through a little bit more, but we didn't. I will have information on Schoology tomorrow. Maybe later tonight, but at some point I'll have the information on Schoology. I plan to try and finish the notes. We'll see how things go. And then I want you guys to definitely try the homework. We'll go from there. Okay? I'll see what happens when I start making recording the notes and seeing how I feel about it. Okay? Please behave tomorrow for the sub.